Today, I'd like to talk about the question why big data analytics is not enough. The world is challenged by climate change, by financial, economic, and spending crisis, by conflict, migration, terrorism, and many more problems. And traditionally, we have addressed these problems with what I'd like to call governance 0.0. Decision making based on anecdotal evidence or small data. And so people have done statistics on this data, cluster analysis, for example, and then decided under what circumstances they would do what thing. And obviously that was not good enough. And so eventually governance 1.0 was invented. Evidence-based decision-making based on big data analytics. And of course, we are now living in a world of big data. In just 1 minute, there are 700,000 Google queries, 500,000 Facebook posts, and a lot more data. As we go shopping, as we move around, all of this leaves data traces. And the idea was that we could now see what is wrong, and where the system is broken, and so we could just fix it, like with an X-ray machine, basically, for the entire world. And so secret services have started to collect a hell lot of data about everything and everyone. And in fact, you are being profiled and targeted, all of you. The estimate about the amount of data collected every day about everyone ranges from 500 megabytes to several gigabytes per day. China is collecting at least 2,000 terabytes per day about its population. Now there are services that offer to see anyone's personality, including yours. So basically, you're being exposed to the public or to certain businesses. And in fact, there are corporations that know more or less what you think. And in fact, the mass surveillance that has happened is probably related with projects such as Sentient World that is trying to simulate action on this planet worldwide. That means there would be basically 7-8 billion agents in that simulation. Those agents would be represented by learning black boxes that are fed by mass surveillance data that basically create digital doubles that behave like yourself. And how is this being done? Well, WikiLeaks, for example, has reported about Vault 7, and there you can see how, for example, the CIA is collecting all the data from smartphones, from computers, through smart TVs, and so on. In fact, the CIA Director Gus Hunt already in 2013 said that we're already a walking sensor platform. He said it's really very nearly within our grasp to be able to compute on all human-generated information. And this includes cameras, accelerometers, and so on. So the question was, can we know everything about this planet, about humanity, about every single individual? Can we build a prediction machine? Asked the military. And of course, they've been working on this. Furthermore, some people have asked, would so much information enable something like a wise king? I don't know why this slide was skipped. So, big data enabling a wise king. That was the idea. And the question we need to ask as scientists, does more data really mean more knowledge? I mean, Chris Anderson back in 2008 had a dream or even claimed that we would see the end of theory. The data deluge would make the scientific method obsolete. So what are we doing here? Now, the issue is this. we have a lot of data, a lot of dots, but that doesn't answer how to connect the dots. And this is what science is about, right? It's actually not so easy to do pattern recognition, in particular if there's noise. So the next video will show an infinity sign plus some noise, and we'll see what the machine learning algorithm predicts to be the shape. So it does not necessarily come up with an infinity sign at all. And this is the kind of problem that we're dealing with. Machine learning may not even converge. In particular, there are power law relationships within the data, as it may apply to some social network data. That's controversial, though, I admit. But anyway, there is this issue of spurious correlation. I mean, the more data you have, the more pattern will be in the data, just by coincidence, such as this one, like number of serial killers as a function of chocolate consumption, right? So if this would be a causal relationship, then it would be very dangerous to live in Switzerland. And so far, I find it pretty okay. Of course, this is just a correlation and doesn't mean anything. Like the following example, which is a little bit funny, but shows you the issue. Like the number of forest fires as a function of ice cream eating children. There is certainly a strong correlation, but the reason is a third external factor, which is heat. And if you would forbid children to eat ice cream or lock them away, that wouldn't reduce the number of forest fires at all. I would think these stupid things couldn't happen to, say, Google. Then actually it's not true. Quite a number of big data companies came up with results that were not sustainable, including like orange cars would break down less often. We're not talking about accidents here, or including Google Flu Trends, which is actually taken offline because it doesn't work well anymore. So we need something better than just big data analytics. The idea that if you just have enough data, data will tell you the truth and you just have to do what the data tell you. No, that's not working well enough. It may work for some things, but it may not work for many other things, and altogether there might be quite a bit of damage created if we just blindly follow data patterns. And so this brings us to governance 2.0. Shall we have artificial intelligence manage our world? Surely there's an AI explosion. So the power of artificial intelligence systems is increasing very quickly, maybe faster than exponential even. And some people expect that we would see super intelligent systems pretty soon. Other things will take much longer, but anyway, we know that already many years ago, computers were beating the best chess players. And recently they were also beating the best Go players, where Go was seeing kind of a big challenge that is much more difficult to crack than chess. And most people expect it would take another 10 or 20 years, but in fact it happened already back in 2016. And then there was AlphaZero, which basically learned how to play the game and win the match by itself, by playing against itself. And then the Spiegel even said, God doesn't require a teacher. So basically it was suggested that now we're basically entering an age where AI systems would be godlike. And in fact, a previous Google engineer established AI as a religion. So you can join that religion. So just like to ask who would like to join that religion here? No, but oh, one, okay. Didn't know. So basically, we would have to obey this super intelligent thing. That's the idea. And so we're living in a new world. Some people think it may be a brave new world even. Decide for yourself. Certainly there's a new currency, which is data. Data is very valuable these times. And there's a new economy. It's called attention economy, and the idea is that even though money may be scarce, attention is an even scarcer resource, and you can buy it actually on the internet if you want to sell advertisement, and basically there is a market for your attention, right? And the point is, whenever you manage to grab the attention of somebody for some seconds, then you have access to the thinking of that person and may be able to sell a product or change the opinion or maybe the voting pattern or whatever. And we also have a new legal system. Nobody told us. But in fact, we can say code is law, kind of at least. Algorithms determine more and more what is possible in our lives and what not. However, these algorithmic laws are not passed by a parliament. This is kind of circumventing our democratic decision institutions. And there's a new society on the way too. So some people have basically thinking about society as a giant machine. And so we could learn basically to run this machine if we just knew about all the pieces that make up society and how they behave, and that's why we have mass surveillance, some people think, and learn to control those different pieces and their behavior. And in fact, the early concept of smart cities was very much about the automation of cities, like logistics, for example. But not only logistics, but it's also about people's consumption behavior and other behaviors. And there are a lot of companies that are involved in these business models. In many cases, they're not talking much about it. But Google, IBM, Apple, and so on are trying to prepare for this business of smart cities. And Google said to want to reprogram the state, and basically a similar thing applies to IBM and Facebook and so on. Just the issue is that we're not being asked how this system is being reprogrammed. We have to accept what is given to us. And so that certainty is not anymore the democratic system that we know of. So a new political system is also born. And of course, people have thought about ways to rule society more efficiently with digital means, with big data, with AI. And something like a digital chapter was created. It's called nudging. And in fact, they got a Nobel Prize. I don't know why this actually skipped the slides. Richard Thaler spoke a couple of years ago over here. And he wrote a book about misbehavior. So the idea is that he basically thinks that humans are misbehaving and that misbehavior needs to be corrected. And nudging would be the way to correct our behavior. Now the interesting thing is, this is not a flock of birds as we know it, because birds are not behaving in a crystalline way. You know, this is a marching pattern, basically, from my point of view. But flocks of birds are not centrally controlled at all. They're self-organized. So I think this is the wrong perspective on society. But a lot of technology is capable, to some extent, to control people. And it's being done within attention economy by personalized information. And a lot of this happens in the context of marketing. But in fact, that technology has also been developed primarily maybe by secret services such as the GCHQ, and in fact the J-Trick revelation of Edward Snowden told us basically that there were methods in preparation for psyops, for psychological operations, and they have been figuring out all the cognitive biases of humans. Of course, in contrast to a supercomputer, a human brain only uses 100 watts of energy, and it takes shortcuts, it simplifies things, and that can be used to trick people. So they mapped out all of this, and for all of these cognitive biases, they developed a digital trick in order to manipulate people potentially. And at that time, people didn't realize that this could be applied to millions or even billions of people. And the outcome is something like this, right? And Tristan Harris has actually confirmed this. So I'm not making this up. Tristan Harris was working in a Google control room, as they call it, and he has given an interesting TED talk where he explains how a handful of technology companies are basically controlling billions of minds every day. So this basically brings us to technological totalitarianism, the attempt to control people's thinking, emotions, and behaviors. And it maybe goes further in China, where now something like a social citizen score is being tested. So basically everything that one does or doesn't do would potentially get plus or minus points, right? If you cross the street when there's a red light, it could get minus points. If you pay your rent late, if you read critical news or have the wrong friends, then you would get minus points. And the citizen score would determine the kind of jobs you could get, the countries you could travel to, the speed of your internet, and whether you can still take the fast train or not. This is now being tested, different versions in different cities, but the idea is to roll out a system by 2020. And some people are asking what will happen in our countries given that we have to solve a sustainability issue. Now, but also AI has some issues, and one of the issues is bias, as also a Google engineer says. Bias against certain kind of people, like people of color or women or minorities. And there is a dark secret at the heart of AI, which is basically it's a black box. AI will come up with decisions, but we will not necessarily be able to understand how it came to its conclusions. And so this brings us to Governance 3.0, decision making based on explanatory models. So it's not enough to have a black box system run our society. We want to understand how certain decisions come about. And that requires data science as compared to big data analytics. And here's an example. So we've been looking into epidemic spreading patterns. So suppose a light shines up on a globe whenever somebody catches the flu, and you would look at the spatial temporal patterns of these lights flashing up. Then you would see a pretty complex pattern. It would be very frustrating because you get a really widely scattered data cloud that doesn't explain you much. So we don't seem to be able to understand the spreading patterns, but this is because the flu doesn't spread by diffusion, as maybe the Black Death many hundred years back. But instead, we have a situation where people use the plane and fly to other places and may infect people over there, and that creates another spreading pattern. It messes up diffusion in a sense. But if we take into account the traveled volumes, that means another data set, we can define an effective distance which would bring, say, Frankfurt and New York City close together because there are a lot of passengers traveling. And within this effective distance, then suddenly we'll see a diffusive pattern again. And so we can determine the place where the flu started, and we can also predict the next cities to be hit by the flu, and so you can prepare for it. You can also see a much better statistics. Now there's a regularity, so basically by combining data and putting in some scientific understanding of the process at work, we can come up with data science, right? That's the idea. And of course, a lot of the systems in our world are complex, and that requires complexity science. And there are attempts to simulate the happenings on the world with something like a world simulator, where there would be kind of 7-8 billion digital doubles of us, and they would be simulated. And the question is how well would actually the prediction work? And there are companies like Recorded Future who claim that we people are pretty predictable. I mean, 90% or so, they claim, of our behaviors, at least those that are interesting to them, can be predicted. But not even identical twins are fully identical, right? And interactions can change everything. We have also heard about randomness this morning that can change everything. In fact, I'm coming back to Michael Mace's paper, and it turns out that a deterministic model was able to predict 96% of all decisions. That's phenomenal in social sciences, it's amazing. But it was not able to predict the macro outcome. Why? Because a little variation could mess up the system. We call this instability. And adding noise, surprisingly, yielded improved results in terms of predicting the macro outcome, right? So that's quite interesting, but it also shows the limitations, basically, of trying to micro-simulate the entire world. Complexity will mess things up. And when systems are unstable, they may get out of control in unpredictable ways. So, for example, these phantom traffic jams may happen even though nobody wants this to happen. Even mass surveillance wouldn't stop it if you could look into the brains of people. Why is this? Because of instability. Small variations above a certain density would be amplified and would create a cascading effect, and eventually cars would be stopped and a traffic jam would form. So society cannot be steered like a car. And that brings us to computational social science. This is why we need it. And computational social science brings together different fields like data science, social science, computer science, and all sorts of quantitative methods, and also disciplinary knowledge. And in the past years, computational social science has made quite some remarkable progress, and I'm just mentioning here some of the examples from our own team's work, but there's a lot more, of course. So pedestrian flows, crowd disasters, traffic congestion, booms and recessions in our economy, opinion formation based on social influence, coordination problems, cooperation, its breakdown and its outbreak and the conditions for both, occurrence of conflict, spreading of crime, but also the evolution of moral behavior or the evolution of social preferences. I'll talk a bit about this tomorrow, and the emergence of social norms. And now we're coming to governance 4.0, which is mechanism design. So rather than trying to control a system by controlling every single element centrally, it's possible to overcome problems such as stop-and-go traffic by slightly changing the interactions between cars. I don't have enough time to show this entire movie, but it's possible to dissolve the traffic jam by real-time measurements and real-time feedback, and by changing the interaction mechanism. So 300 years after the invisible hand was incepted, the Internet of Things can make it work. That's the idea, because this is where we can get the real-time data, and this is how we can produce a real-time feedback. And now game theory makes a contribution to the field of mechanism design. Mechanisms that can help to self-organize a society and cooperation. And there are a lot of mechanisms actually that can promote cooperation decentrally, such as direct reciprocity. So that means repeated interactions. I help you, you help me, that's the concept. Multidimensional reputation systems to incentivize responsible use and higher quality, but also success-driven mobility, for example, a surprising mechanism from my point of view, peer punishment, altruistic signaling. This is another study that Michael Mays and I have started together, and merit-based matching, that is a study that was done by Heinrich Nax and myself and others. And qualification could be also such a mechanism promoting cooperation, by basically giving more access rights to people who have advanced on this scale of responsible behavior. And so basically what I believe we would need is a global system science. That means a field that would work on finding mechanisms for a better world. And that was proposed among others in Nature some years back. I personally believe that it's not enough to describe the world we're living in, because this world is currently going through a transformation, a digital transformation, a sustainability transformation. The world is changing dramatically. And we can contribute to the organization of data and coming up with mechanisms for the 21st century society, in a sense, a new civilization maybe. And that brings us to governance 5.0, because I think what we need to learn is a participatory management of complex systems. We need to be able to mobilize collective intelligence and collective action. And so we need to upgrade the smart cities concept that I mentioned before by collective intelligence. So it's not just enough to have technology-driven cities. We need to enable citizen co-creation. We need to design those cities for our constitutional and cultural values. Jeroen van Hoven will be talking about that tomorrow afternoon. And now, that also requires to build digital democracy, because that is actually about enabling collective intelligence with digital means. And with the very few means that we have tried to contribute to some ideas and build some simple platforms. Empower POTUS is such a platform. It actually won the ETH policy challenge. Influenza, GripNet, something that would help people to take care of their own health better in a way that empowers patients. asset, a product finder that would support more sustainable consumption, more responsible consumption, and nervousness. And now we're working on the concept of city Olympics. It means a friendly worldwide competition between cities and regions to come up with new solutions for a better climate, energy efficient systems, sustainability, and resilience. Those solutions would then be open source and Creative Commons. That means everyone could take them, combine them, develop them further, and that would enable combinatorial innovation. And one of the things that we're very much interested in is a system that we call the socio-ecological finance system 4.0. It's a multi-dimensional real-time feedback system that we envisage in order to promote participatory sustainability. With this, I'm coming to an end, and I hope if anybody here doubted that we need computational social science, that you would now be fully convinced that this is one of the ways to go in order to make progress towards a better future together. Thank you.